All right, let's look at the harmonic series and let's try to make this short and sweet. This is the harmonic series. There's no fancy bells or whistles. You just keep progressing through n equals 1, 2, 3, 4, 5, 6, 7, 8, and you keep making that your new denominator for your next term in the sequence. Well, if this is a convergent series, then it adds up to a specific number. If it's a divergent series, then this number ends up being infinity. Well, the theory says you should go ahead and think about the sequence of partial sums. That's my sequence of partial sums. Do I see a clear limit? No, but I'm not positive. Like I've mentioned in probably other videos, I'd probably need to do a lot more analysis if I wanted to be positive that I'm not seeing a trend. Going out maybe 4 n's is nothing compared to heading out towards infinity. Well, I'm going to spill the beans though, and I'm just going to tell you, hey, the harmonic series is divergent. If you've already seen the videos on the geometric series, you see that there's some tests and so on that you have to do based on what type of geometric series you're working on. Not so with the harmonic series. You can just memorize that statement and you know that the harmonic series is divergent. So that is telling us our sequence of partial sums really was not leading towards a specific value. A little informal proof, maybe it's a formal proof, I don't know, and a review of something you learned earlier. We could prove this by simply doing the indefinite integral. When I'm going to add up from 1 to infinity all the values of 1 over n, that's the integral from 1 to infinity of all the values of 1 over x. Well, last year you couldn't have done that integral, but now this year you can because you say, hey, infinity, I'm going to make this an improper integral. You go through all those steps and you end up with a value of infinity, which tells you this is a divergent integral, which also tells you this is a divergent series. Want to point out another thing. The harmonic series, as simple as it is, can come in other forms. So for example, 7 over n, you might say, well, that's not the 1 over n that was at the top of this paper, but it really is a harmonic series. The denominator is just an n, so I would go through the various n's and it would look like that. That's a harmonic series, so I can tell you that's divergent. Another way to write this, though, by the way, if you think about it, every single one of these terms is the same as the terms on the original harmonic series we looked at, except each one of these terms is multiplied by 7 in the case that we're looking at down here at the bottom. So I can simply rewrite this as that if I feel like it. Here's another harmonic series. This one has a negative sign on it. Well, everything else is the same, 1, 1/2, 1/3, 1/4, but I just have a negative on every term. So some people might write this as -1, -1/2, -1/3, -1/4. Totally fine. And if you feel like it, you can rewrite it this way. That's it, short and sweet. The harmonic series is divergent.